line integrals will also have this notation. F is the, whoa, that is not the red I wanted. F is the vector field, and R is the, well, dr is the differential vector. So if we have R is equal to x unit plus y unit plus z unit, when we do dr, that's going to be dr x unit plus dr y unit plus, oh, my bad, not dr x unit, dr y unit, but dx x unit plus dy y unit plus dz z unit. This notation kind of simplifies things a little bit. So if we have our f, I had this example, 3z squared y unit plus 7yz unit, and dr is obviously that. If we take f dot dr now, 3xy times dx is just going to be 3x unit, and then if we were to do the y unit, there's no y component, there's no z component, but this isn't the full story. So when we do this notation, we're going to be integrating over some curve. So if we had that same function, 3xy x unit plus 3z squared y unit plus 7yz unit, we're also going to say it's going to be going along the curve. Let's say along this curve. So we have this is the curve. So then we take r prime of t, and that's just x unit plus 2t y unit plus 3t squared z unit. And of course t is going from 0 to 1. So now we're going to do f of r of t, and this looks pretty complicated, but it's really not too bad. So we have 3xy x unit, so that's going to be 3 times t squared x unit plus we had 3z squared, so that's 3 times t cubed, I believe. Yep, t cubed y unit, and then 7y z unit, 7 times t squared z unit. And this is just 3t cubed x unit plus 3t cubed y unit plus 7t squared z unit. That's f of r of t. Now, when we do f dot dr, because when we use this notation, f is really f of r of t, which is really confusing, but if you write it out this way, it becomes a little easier to understand. And so remember, now this is our dr vector. So now when we do f dot dr, we have 3t cubed x unit dot x unit plus 3t cubed y unit dot 2t y unit plus 7t squared z unit dot 3t squared z unit. When it's all said and done, we have 3t squared. Nope, that's not a square. That's a cube. Plus 6t to the fourth plus 21t to the fourth. This gives us integral from 0 to 1, 3t cubed plus 27t to the fourth dt. So now we integrate 3t to the fourth over 4, 0 to 1 plus 27t to the 5 over 5, 0 to 1. That's 3 over 4 plus 27 over 5. And times that by 1. 15 over 20 plus 108 over 20. 123 over 20. And that's the final answer. So with these types of problems, it is a little confusing because if we're given f and we could have also probably integrated this with our original maybe, but we would have also had to find what the curve was, and this curve is maybe a little harder to you'd have to unparameterize it, and I'm not really sure how to do that off the top of my head anyway. Yeah, I think the hardest thing is with this is this notation. If you see it, oh, it's f of r of t, but this was just an easy example in physics and other, in like classical mechanics and other subjects of physics. You'll see a lot of line integrals, and they're not as this simplified.